Hi guys, welcome to the Graphics Guy. Today we're going to have a quick look at a topic that comes up a lot and causes a fair amount of grief and hardship, I think, to some people, and that's looking at what I have here is what I would call a plane in space. It is a bit like having a set square, like a green set square there, just floating in, suspended in midair. Then we've got what I would call the reference planes. Here's our vertical plane, our horizontal plane, the XY line, and again this all ties back to the basic fundamentals that the XY line is where the vertical plane intersects with the horizontal plane, and then we've got this plane here, ABC, that's suspended in the air. So the elevation there is projected in, so that's our front view. Here we see looking down from above, what it appears like looking down from above is our top view or our plane. And what I want to look at here is how do we find an edge view of this plane. Now an edge view, we're going to see that triangular plane here appear as a line, as a single line. And then finally we're going to look at how to find the true shape of it, then what's the real size of it. So let's get started. Now, in another video I will go through the setting up of these using the coordinates, but for understanding these questions really you don't need to work with the coordinates. If you draw a triangle in elevation representing this view here, and all that matters is that you keep the corners of the triangle directly beneath here. So I'm going to pick point A that's in here, because point B is a long ways from the vertical plane. I'm going to keep point B down here, and C is somewhere in between. So I'm going to put point C here, and that is going to work for us. So just join, trade them up, and remembering now I'll label this. So that is this projected view here onto the vertical plane. This here is the projected view down onto the horizontal plane. Now what I want to look at here now is the idea, if I take a horizontal line in elevation, and I'm going to call that CX. Now we know that point X is here on the AB edge. So I'm going to project X down to plan. There's X. I'm going to join that back to C. Now that line that I took there, CX, that is a horizontal line on a plane that's just suspended in the air. But this CX line has some very important properties. First of all, it is a true length in plan, TL for true length, and it is horizontal. Because it is horizontal in elevation, it is horizontal in plane. What I mean by that is, even though this set square is sloping, that line represented by the red pin there is horizontal, as in if you were walking along it, you wouldn't be going uphill or you wouldn't be going downhill, you would be just walking level on a sloping surface. But why it has some important properties is if we take an auxiliary view at that angle, so I'll just line that up here. So we want to take an auxiliary view looking at that angle, put an XY line here. So here's our first XY line, and this is our second XY line. Now, following the usual rules of auxiliaries, we're projecting from here, so from the last XY line back, I'm going to take some distances. So B is low down close to the ground. C is the middle height. And finally, A is our highest point vertically. Now, when I join these, we see there I have a perfect edge view. I'll just label this A and B and C. I'll actually call that CX. And I'll just put in here that red dot, because what we're seeing now is a point view of that line. CX, that horizontal line, appears as a dot in the way that this pen, if you look along it, can appear as a dot. And the whole basis of this thing is, if you have a line on a plane, and I'll just twirl that around, when you see a point view of the line, you have to see an edge view of the plane. That's the theory behind it. So we now have an edge view of this plane. So the next thing I want to look at now is how to see the true shape of the plane. So if I was a person and I could position myself to look down here at 90 degrees to this, I would see the true shape of that plane now. So I'm going to just get that angle, turn the set square around, and I'm going to project these down here perpendicular. I'm going to put in another XY line here anywhere. So this is my XY line, XY1, XY2. So again, same rules apply. I'm projecting from here, from this edge view, which I'm going to label actually. So that there's our edge view. So projecting from here, last XY line back. So this is my distance for B. This is my distance for C. And here's my distance for A. Just label them. Now, that there is the true shape of ABC. And I'll also put in there the CX line along it. So that is the true shape of ABC. And just to show you what I mean by that, if I get the size of AB here, swing AB, it is way bigger here, or way bigger than AB in that view, because when you're seeing the true shape of a plane, that's the biggest it can be. That is the real size of it. And it's like looking at this set square. When it's turned, when you're looking perpendicular at 90 degrees, you see it looking as big as it can be. But the more I twist it, the smaller it appears, until like it becomes a line, is I suppose the smallest that it can be. But when you're looking at an angle, it appears smaller, and the closer you get to looking perpendicular, the bigger it appears. So that's the concept behind it. So that's some of the most basic stuff to understand there, how that's a projection of the plane that's suspended in the air, and that basic system or rules of taking a horizontal line in elevation, get that horizontal line in plan, look along it to find a point view. That will always give you an edge view of the plane, and if you look at 90 degrees to the edge view, you will see the true shape. And an awful lot of these questions is based on understanding that and being able to do it. So that's a good starting point. I hope you enjoy that.